Hey, y'all, in review number 4, we are going to talk about using lines and curves of best fit. So, this is where we're putting tables into Desmos and we are trying to write the equation of a line that is close to the points in the table. And this is the only video of this review, so there's no follow up except for to do some practice after the video is over. As always, please ask questions if you have them while you're working through. You can always pause or ask your questions after the video. So this is just a quick way to show you where we get a table from. We're going to get a table by clicking the plus and choosing table. And then let's enter this data into our table here to just to practice. And I usually enter the numbers on the left. So my X numbers first, and then I'll go in and add my Y numbers. And it's always worth the few extra seconds that it takes to make sure that you've copied correctly from the problem into Desmos so we make sure we avoid any incorrect answers. And so you should be able to see the points graphed. So each of these rows is a data point. So you could click on one and see this one's 2, 3. That comes from here. You could hit this zoom fit and it'll find your data points for you. So let's say we typed in a table and we couldn't see any points graphed. You would just hit that zoom fit. Anytime I zoom around, that'll pop up again and it'll zoom right in for me. If I want to graph a line that's close to this, that is this Y1 squiggly, that's the way I say it, MX1 plus B. And these are formulas that we'll have to remember. So if I want to draw a straight line that is close to those data points, I'm going to type right in here Y1, so Y, and then the number 1, then the squiggly, and then MX, the number 1, plus B. And you can see it's graphing a line. And you can see that line is close to all my points. And then we're going to get some information here. M is the slope of my line, and B is the y-intercept. So if I went and clicked right here, you can see it says 1.4, just like it says underneath that word parameters. And the slope of my line is 1.02857. We might round that to 1.03. Another letter it gives you is this r squared and r. And so we're going to look at r real quick. R is a number between -1 and +1. The closer that number gets to +1 or -1, the stronger the relationship. So I'm just going to say for sake of having like an idea, anything from zero point 0.8 to 1 is strong. So if I were to get an R value that's like 0.8 or 0.84 like this one, or oh, that's R squared, or like 0.84 or 0.91, that's a strong relationship. That means there's a very strong relationship between whatever our X and our Y's are. Somewhere in like the 0.5 to zero point 0.7 range, that's a moderate relationship. And anything less than 0.5, I would say, is weak. And that is true about the negative. So negative zero point 0.8 is strong. Negative zero point 0.5 is moderate. Negative zero point 0.4 is weak. If that R value was a 0, that would mean there was no relationship. Sometimes we want, or a straight line doesn't fit our data points, and so we would use this curve of best fit. So if you see the words quadratic or quadratic curve, we would use that one, y1 squiggly ax1 squared plus bx1 plus c. And we're getting a lot of information here all at once, so please, if you do have questions, ask so that I can clarify individually. I always clear everything out when I start a new problem and I get a new table. Here I'm given data points and not a table to copy. So we have to be careful. The first number is an X, the second number is a Y. So you could label them all. And we're going to put these into the table. So I'm going to pause here and put them into the table. and then come back. So I've put my data points in here, and I'm going to click the zoom fit, and it's going to show me them. This is asking for a quadratic curve of best fit. So that is when we're using this formula. We want the quadratic. We want it to look like a parabola. You can see the points kind of make this U shape. That's going to tell you it should be quadratic as well. Please practice typing this in on your own. So you should be doing this as well. If you have to pause to do it, you should. So you can practice typing it in. So you make sure that if you have any mistakes, you can ask now when you cannot ask on the test. It's going to give us three parameters, A, B, and C, that we would plug in for A, B, and C. So we want to look for the equation that has 1.7 x squared plus 2.9x minus 5.2. And that's going to be this one right here, D. I'm going to clear all this out, and I'm going to go ahead and pause and put this into a table, and then we will find an answer. So here I have the table, and again, I'm going to zoom fit. I can't see anything, so if I zoom fit, it's going to show me where those points are. We want to use a line of best fit, so I'm going to type in y1 squiggly mx1 plus b. We're using y1 and x1 because in our table it says x1 and y1. So if you do not clear out the tables, your next table would say x2 and y2, and we would not be able to get our line. So just make sure you clear out every time so that we're always working with x1 and y1. And so this one's not looking for an equation, even though we have all the information. You can see there again, we have R 0.99. That's a really strong relationship, close to 1. That means there's a really strong relationship between the months that this bus is used and the amount of miles that it's been driven. So the more or the longer we own it, the more miles we drive, and that makes sense. We could write an equation. We have the slope and we have the y-intercept. We have that y-intercept down here, negative 5,362. It's asking us to make a prediction for a bus that has been used for 40 months. So we want to know how far we would predict we would drive it if we had it for 40 months. So months are x's, distance is y. One way we can do this really quickly is we can type in here, I want to know what happens when x equals 40. And you can see it graphed a line, and those two lines cross. This is an example of systems of equations that we've talked about previously, but the solution is going to be where those places cross. And you can see that x is 40 because that's my 40 months. And this 91,426 is my miles driven. That is a prediction. So if I want to know which one is closest to the prediction, it's that one there, 91,400. I'm going to pause one more time and put this data into the table. You're going to see this on the next several slides. It's the same table. So if you put it in once, we can use it for the whole thing. So go ahead and we'll pause here and put this data into a table. Okay, so you should have a table in there. You can see the green dots, but it's always good to go ahead and zoom fit. And then it sort of zooms it in for you. And so we will work with this data set, but right now they're just kind of asking, hey, what questions do they ask in order to collect this data? And so we have data on the average number of hours per day that we would say students use their cell phone. And then we have their GPA, their grade point average. And so we probably would have wanted to ask the students what is their grade point average. And then we would probably want to ask them, how many minutes do you spend on your phone each day? And so we're trying to see, is there a connection between how much you're on your phone and what your GPA is? And so if we look at this, this looks like a straight line. So we probably would say that this is a linear relationship. Our points as we go to the right. So this x-axis represents how long you're on your phone. This y-axis represents your GPA. So as we increase the amount of time on our phone, it looks like the GPA is going down. So these points follow a pattern that is consistent with more time spent on the phone, resulting in a lower GPA. So that is the relationship that exists here. It's linear because it looks like we could draw a straight line through it. And as my time increases, my GPA decreases. It's telling us what the correlation coefficient is. That's that letter R. So if we did y1 squiggly mx1 plus b, it would say R equals negative 0.99. Even though it's negative, it doesn't make it weak. Whenever we have something close to -1, that means there's a really strong relationship. So we have a strong relationship here between how much time you're on your phone and your GPA. The closer that number gets to 0, the weaker the relationship. And this is definitely not a positive relationship because it is a negative number. So we are going to want to calculate the line of best fit here. So let's type in y1 squiggly mx1 plus b. And we can get a slope and an intercept. We want to select the options that compare our slope and intercept from our line and then the slope and the intercept from this other school. So the slope there is negative 0.35 and the intercept's 3.8. And so if we look at these two, we want to pick the correct option. The slope of this new line, negative 0.35, is actually steeper. And so we would say that um, this school has a steeper slope. The intercept is what happens when we plug 0 in for x. So for our original line that we graphed here, if we plug 0 in for x, that means the student would have a GPA of 4.16. If we plug 0 in for x for the new school, they'd have a GPA of 3.8. So that's kind of what's being said here at Lincoln. If they're not on their phone at all, we would predict they had a GPA of 3.8. And then for both schools, there is a negative relationship. That's why the slope is negative. That's why the R value is negative. As you increase your phone use, your GPA goes down. And so, if we were to make a conclusion, that's the conclusion we would make. The more time students spend on their cell phones, the lower their GPA. If you have any questions about any of this stuff, this was a lot in a relatively short amount of time. Please ask. If you're having trouble putting any of this stuff into the calculator, interpreting any of the numbers, make sure you ask. There are practice problems for you to do. You should check your answers while you're working. You should ask for help if you get stuck with any of this so that you can use these ideas on the SOL. Take your time and good luck.